Hello gentlemen, purpose of this video is to analyze graphs and find out some important characteristics of graphs such as zeros, whether it's increasing or decreasing, or to find relative max and mins. Let's first start by talking about the vertical line test. Vertical line test is basically a test to look at a graph and to see if it's a function or not. And basically the vertical line test is saying that if the graph is a function, then a vertical line will only intersect the graph at most one place. And I guess the question is why? And it goes back to what we talked about in terms of defining a function. Remember, each member of in the domain of a function gets mapped to exactly one member in the range. Okay, so each member of the domain gets one member of the range. So if we have a member of the domain get mapped to two different parts, two different members of the range, then the vertical line would hit two spots, and that we know is not allowed. So let's look at a couple examples here. Here's an example of a graph. If I look at a vertical line here, close enough, we'll see that this vertical line intersects the graph twice. Once up here, once down here. And therefore the vertical line test tells me that this is not a function. Again, this point right here, whatever it may be, gets mapped to this point in the range and this point in the range. And we know that's not allowed by the definition of a function. So that one's not a function. And this one here is actually a function. I can draw a bunch of different vertical lines. And you can see I'm only intersecting at one spot. Okay, so that one is a function. So vertical line test is a quick way to look at a graph and tell whether or not the graph is a function or not. Talk about the zeros of a function, and I think you're somewhat familiar with this, but let's talk about it anyways. The zeros of a function are the x values for which f of x is equal to 0, or the x locations where we have the x intercepts. So let's look at a graph here, right there, and let's look at finding out where the zeros are. Here's my function, x cubed minus 3x. If I want to find the zeros of this function, I simply set that equal to 0. I want to solve this equation, x cubed minus 3x is equal to 0. I should say I have three zeros. One's going to be right there, one should be at the origin, and another one's going to be over there. Okay? If I want to solve that equation, what I'm going to first do is factor, like that. Again, I have two numbers that are multiplied together that get 0, so that means either this is 0 or this term is 0. And so what we get is we get x is equal to 0, which is right there, our origin. And the other solutions are going to be plus or minus root 3. So if I plug that in, I get 0 on this term. Basically what that's telling me is that my x-intercepts are negative root 3, 0, 0, 0, and root 3, 0. The zeros of the graph, if I ask you what are the zeros, you would tell me x is equal to 0 or plus or minus root 3. Okay? So when you're asked to find the zeros, simply set the function equal to 0 and solve for x. Another important characteristic of a function is whether or not it's increasing or decreasing. A function is increasing basically as x gets bigger, the function values get bigger. That's basically what all this is saying here. In other words, if I'm on an interval and x2 is bigger than x1, that means that f of x2 is bigger than f of x1. Okay? Characteristic of increasing functions is usually a rising up like that. Not always a line, can be more of a parabolic shape or something like that, but it's always going from bottom left to top right type of motion. A decreasing function is basically the opposite. Excuse me. If the x values are getting bigger, then the function is getting smaller. You know, something along this type of motion here, where I'm going from upper left to lower right, we're going to be decreasing. So as the x values get bigger, the function values get smaller. Let's look at our example of the same graph that we've been using. Let's look at this graph here. And as I move in this direction, x is getting bigger. And so is the function value. See, it's increasing here. But all of a sudden I get to this point right there, and I start to get smaller. till I get to about this point here. Then I get bigger again. So basically on this part of the graph, right there, I'm increasing. Alright? And I'm increasing over here as well. Over there. So I'm increasing right there as well. Over in this part of the graph right there, I'm decreasing. Okay? As my x values are getting bigger, my function values are getting smaller. Okay, so I'm going to increase here, decrease, back to increasing. Another important point on this graph, let me get rid of all this, I want to talk about is a couple important points. And they're called the relative extrema. Relative maximum values and relative minimum values, also known as relative extrema. And basically what it is on some interval, I have a value right there that is bigger than all the other values. Not for the entire range, but on a certain interval. Say, from negative infinity to negative a half, there's a value right there that's bigger than all the others. And we've got one over here that's smaller than all the others on a certain range. We call this point down here a relative minimum. Whoops. Relative min. Okay? And this one up there is a relative max. It's a maximum value, not on the entire domain. If it was, it would be called an absolute max. But it's a relative max in that general area up here. And basically what we're looking for when we're talking about relative maxes and mins are peaks and valleys. Here's a formal definition of relative max and relative min. But what I want you to think about is a relative maximum as a hill, okay, or a peak of the graph. And a relative min is going to be the valley. So anything that looks like that is going to be a relative max. Anything that looks like this is going to have a relative min, down the bottom and down the top. Okay? Hopefully that makes sense to you. We're going to use our calculators to actually find a bunch of these, but I wanted to get the terminology down. Some practice for you guys. I want you to read section 1.5. These 3 examples, definitely worthwhile. Make sure you check those out. And then I give you some practice problems at the end of the section. Again, we're going to use our calculators to learn how to do that. I'm going to do the next video is going to be basically using your TI-84 to find zeros, to find maximums, to determine intervals on when we're increasing and decreasing. So next video, make sure you have your calculator ready to go. Okay. Just summary, we talked about basically 3 major points. We talked about vertical line test and the fact that if a vertical line intersects a graph more than once, it's not a function. We talked about finding the zeros of a function, and we talked about increasing, decreasing, and relative extrema. Okay, so hopefully those things make sense. Again, we will practice with the calculator, get a little bit more visuals. Any questions, make sure that you guys email me. Okay, have a nice day.